National Institute of Technology, Trichy, in the year 1992, and he also got his M.Tech degree from Indian Institute of Technology, Kharagpur, in the year 2000, and he is awarded PhD degree from the same institute, Indian Institute of Technology, Kharagpur, in the year 2006. Our speaker is having more than 67 publications, and I'm very honored to invite this speaker for this webinar session. Welcome, you, sir.
I request the participants to place your call on mute. Yes, ma'am, please continue, ma'am.
Yes, sir. Over to Vadivel, sir. Dr. Vadivel, sir.
Okay, thanks, madam.
Thank you, sir.
So, it's nice to be there again with M.A.M. people. So, today I'll talk about some of the data science concepts. As you know, the data science has faced a lot of attentions from the academia and industry, since it has a lot of applications. You look into any domain, you'll have the applications of data science subjects. So now I'll try to present something because I'm being given 1 hour. So within an hour, I'll try to cover as much as possible, so that you people can understand if it is possible. So I'll use the slides for you. Give me some time for data science, TP, recommender system. Okay. So I'll share the slide now, entire screen. Share. Okay, I can't share or what? Am I given permission?
Yes, sir. It's there, sir.
I'm not able to share. It says turn on capture. Present now. I'm going to present now.
Just click on present now, sir, and choose the screen, sir.
Entire screen I'm saying. Okay. Share. My PPT is visible?
Yes, sir. It's loading, sir.
Okay. Okay. So this is what I thought of presenting you. It is the concepts of data science. We can say nuts and bolts. So what all you have inside the subject, because this subject is becoming very, very popular. Now, this is what my agenda today. So I'll have overview on data science, and you should know where to look for the materials and then data set, programming tools, etc., etc. Is involved in the data science paradigm. We'll have some discussion on how to ask questions and how to answer. Rather, I'll put it in this way: how to ask right question and then get the right answer. This is what we are interested in discussing. The value of the data will be discussed. Let us see what are all the opportunities in data science, and then we'll see the challenges. Actually, it is like this. Say, asking the right question to the right people and getting the right answer from the right people is very, very important in data science. Now, what do you mean by that? So, As far as data science is concerned, in general, we ask questions to the data. So you can see that the question is asked to the data, that is what the diagram shows, right? And then the data answers the questions, and again it goes to the question. It is a loop. Okay. So from this picture, what we can understand is that the data science field asks the questions to the data. So I can say it is the right question, and then you get the answers from the data, so believed to be right answer. So if you feel that the question is not proper, you remodify your question and ask it once again. And if your answer is not correct, then ask the data to really look for the correct answer. Okay, so this is how the entire data science paradigm is formulated. A simple model. Okay, we call it as a kind of feedback mechanism. So you ask the data the question, or the right question, and then you get the answer, a right answer. If there is an anomaly, then you go on into the loop and get the things done. Now this will be interesting to note. How will I do all those? Okay, how will I do all those? So you have, as being a computer science people, you know that there are a lot of algorithms, okay, a lot of methods available to do all this. Now let us look into the other points. Since there is a hype in recent times on data science, but it is not new to us. If you're a computer science faculty, definitely you will know that there was a subject called, or there is a subject called data mining and data warehousing, etc., etc. So this has enlarged from these subjects, okay, and all the concepts which are being used in warehousing and then mining is applicable to data science, but not always. There is a restriction, there is a kind of constraint. So the subjects, understanding, methodologies, algorithm which works on data is in existence for more than 100 years. Okay, so it is being used by many of the scientists and then researchers on data. Now, since the data has become so huge in terms of terabytes, petabyte, etc., etc., the conventional algorithms used in data mining and warehousing is not applicable, okay, because of the size of the data. And the data science has change the life, because the data we have called as big data. So what do you mean by big data? Is it that so big? What is the size? Is it terabyte or petabyte, or it is more than that? Actually, again, big data is another subject altogether. So for the time being, we'll assume that big data means big data. Say we can say terabyte or petabyte, etc., etc. And moreover, we have lot of information flowing in the social media. We call it as digital footprint. And these data are so much growing. I mean, it is growing like anything, that the data has become big data. And the source of data is, in general, is unstructured from the social media. But in addition to the unstructured, you also get the structured data. Say, for example, if you get the students' information from the university, you will find that all the data is structured, because you will see that the semester information is structured, the result information is structured. In contrast, if you look into the social media reviews, blog, comments, etc., etc., these are all unstructured. So the big data in general is the collection of the structured, unstructured data, and then it grows every minute, every second it grows. That is why people do call it as big data. In addition to that, the data science also concentrate on a topic called neuro-linguistic programming. What is neuro-linguistic programming? Say, for example, in social media, if you write a review, if you like, dislike, I can consider that as a Boolean. But if you write a review is in the form of a language or a text. Okay, so you write in Tamil, you write in English, you write in Hindi. So I need to understand what is being written And what is that? People do go for social network analysis, polarity estimation in terms of emotion. Likewise, people do a lot of research. So, a linguistic programming is also heavily used in data science aspect to get the meaning of the linguistic text written by the users in the social network. Okay, and in a nutshell, if I want to say what is being used or why are we using data science concept in a bundle, it is for prediction. You are going to predict the present and then future. So the algorithms methods which will be working on a data in general do the job of prediction. Okay, and it could be a manufacturing industry, or it could be academic industry, or it could be any other industry, because people do rely on the data for predicting the present and future, so that there is a business model or business intelligence. Okay, so in this line there are a lot of algorithms available, people have proposed, and many are, in pipeline. People are proposing new algorithms because of the demand from the data science group. So uh, as a nutshell, it is to predict the present and future using the data. Now, what are all the tools so that we can practice? Is that R is a very popular tool. RapidMiner is a popular tool. And in addition to that, Python is very popular tool. Python is being used heavily in data science area, so that the coding is very fast and you get the result. Okay, so this is what I want to cover. Now let us see what are all the skill set you require for data science. So you need data analysis, and you need a mathematical ability, and you need computational skill. So as far as data analysis is concerned, you can say data analytics, etc., etc. The first skill required or domain you need to understand is that data remediation. Okay, data remediation in the sense that you should know what is the data, how the data is fetched, what are all the different columns, what are all the different fields, whether it is object, whether it is integer, whether it is float. So all those information should be known as far as data remediation is concerned, so that you are immersed into the data. The other important aspect under analysis is that EDA, we call it as EDA, exploratory data analysis, is very important, because I tell you, since we all faculty members, we may be teaching the same syllabus for 3 to 4 years, 5 years, and then you can go without any notes to the class and then go teach if you teach a subject for 3 to 4 years. But in the industry, it is not like this. Industry, every day new problem is introduced. You have to face new challenges. So one of the challenges is the domain. Say for example, if you join a project today, the project may be related to medical domain, and tomorrow you need to work with a wireless domain, say for example. So in those scenario, you need to immediately get into the domain and acquire the domain knowledge. Then you need to work very fast. So in the data science context, exploratory data analysis is used when you are working on a data where you have no knowledge on the data. You do not know the data. What is the data? You are given the domain name. Okay, this is the medical data. So you need to look into the data. You need to understand each and every column. You need to understand where the variable types. Everything you need to understand quickly. So for that, the exploratory data analysis is very much useful. So this will be used by many of the data scientists or data engineers to understand the data. Why I'm emphasizing so much here is that if you don't understand the data, you cannot come up with a data driven model. And if you don't have a data driven model, there is no data science available. So the foundations of any of the data science based problem is that the data. So the data has to be explored heavily for the analytics. I mean, you need to do EDA so that you understand the data based on which you will come up with a data-driven model. So once you are successful in data-driven model, the modeling solution. So we call it as data-driven model and the modeling. How do you model the data? Okay, what will be the input? What will be the output? What will be the questions asked? Okay, what are all the features extracted? So likewise, you need to do a lot of modeling solutions. So once you are through, then that's it. You give the input and you get the output. So output should be communicated. That is what written as communication of results. Okay. So communication of results as far as data science is concerned, it's an art. It is like this. Say, for example, if you get into an industry, IT industry, and then if you're in a project, you'll see that there will be a logical requirement, there will be a frills requirement, that is GUI, guy. So in general, if someone is very good at logic, he may not be good at presentation. Okay, and presentation in the sense that not the vocabulary presentation, designing the presentation. It should be beautified, it should be balanced, color palettes, etc., etc. So the communication of the result is very, very important in data science, because you cannot just show the rows and column of the data because the data is so huge. So how do you handle it? You should have a kind of graphical representation, which is the representative of huge data. So the result should be communicated effectively so that people do understand what is there in the result, and any prediction, or are we progressing in the right direction as far as manufacturing is concerned, or the business is concerned. So it's a kind of, the report you generate using the data model to the people so that your result will be communicated effectively to the crowd. So these are all primary understanding steps in the data analytical skill set. In addition to that, we have mathematics skill set. Actually, I tell you, if you have mathematical notion, if you have mathematical understanding, then you have very good opportunities in data science, because mathematics is the basic of all the data science tools. So say, for example, you need to go for qualitative analysis. Yes, you need to. And you should also do quantitative analysis. And yes, you need to. A lot of hypothesis testing will be there. Z testing will be there. So likewise, there are so many areas where you need to, really improve your skill sets. In addition to these, the 4 points I have listed, there are other domains, say numerical analysis. Okay, numerical analysis, linear algebra, even discrete mathematics, differential calculus. These are all the mathematics, okay, are subjects which are very much useful, or these are all prerequisite if you are really into the data science. Okay, if you are really into the data science. Finally, we have computational skills. You need to have computational skill, otherwise there is no scope. If you're even if you're teaching, we need to have computational skill, how to use Python for say data science, plotting, etc., etc. So as far as computational skill is concerned, I have listed some of the libraries of Python, say matplotlib, pivot table, data importing, data visualization, VLOOKUP. So these are all some of the libraries used. And my understanding is that if you learn quickly Python and R, then you can pull on, you can really understand the coding, etc., etc. If you have any questions, you can stop me and then ask at any point of time. Okay. Now let us slowly get into the technical part. So, it is. I need now to elaborate so much how data science is in existence in our day-to-day life. Say, for example, whenever you go get into Amazon.com, eBay, Netflix, or any other e-commerce website. Okay, let us be so specific that if you browse into e-commerce websites, you will see that on the website somewhere you will be always suggested, will be given a suggestion for a product. Say if you purchase a mattress, you'll find on the suggestion for purchasing pillows, pillow cover, mattress cover, bedspread. Likewise, you will get a lot of suggestions, and most of the suggestions are sponsored. Okay, so this is the revenue by them. It is a sponsored. Similarly, if you look at your mail in Gmail, or if you are in Facebook, you'll always see that the sponsorship will be popping up, even if you're in YouTube. So these are all the revenues generated by them. Now, why should they do that? Now they have understood your browsing behavior. If you are into the social network, if you are into the e-commerce portal, they have understood your purchasing behavior. So it is like, the entire data of you and me is collected, and based on which a data model is created, so that the suggestion is given, and from which the advertisement is being charged, and if you purchase an item, the commission to them. Okay, so this is how the data science, the basic should be looked in, as far as the financial terms and then the application domain is concerned. Okay, and you will also see that the Gmail filters the spams, etc., etc. How does it being done? It is being filtered based on the email category. So automatically the spam is being filtered, and you'll be wondering how Netflix predicts the shows. For example, I have a movie. I do not know whether I'll be in a position to show you or not. If you are watching a movie, two to the movies from Netflix, and if the category of movies are under same, next time you'll see that you will be given a recommendation based on your movie looking pattern, watching pattern. So the entire behavioral taken, and it is being treated as feature kind of thing. Now I can tell you one more thing, because in Tamil Nadu, DMK has hired Mr. Prashant Kishore. You might be wondering why. What does he do? If you see that, it is data science. So what do? They used to collect the data from each and every nook and corner of Tamil Nadu. They penetrate everywhere, and then collect the data from each and every people. Now they segregate the data into locality. Then they come up with a kind of, the understanding of locality, that okay, this locality needs this kind of options, or their demand is such. So whenever there is a campaign, the leader will go to the locality and then speak what is their demand, okay, what is their requirement. But the local people will be wondering how our leader come to know that these are all our demand, these are all our requirements. This is being done by the people. It's a collection. So this has started from US president selection campaign strategy. So the entire strategy is based on data. Okay, so I think by this time you understood that what is the data science, and there is a very high demanding job called data scientist. So what is the core job of data scientist? Is to understand the data, extract the useful information, which is nothing but the features, and from the features try to have a model, and model will be used for solving the problem. Solving the problem in the sense that it is not only to predict something, it could be also many other, the business intelligence, etc., etc. Now, the data science, again, I'm continuing for some more time for the discussion. So why sudden demand? I said there are lot of demand even in the COVID-19 pandemic situation. There are a lot of demands. There are a lot of demands for data scientists, data analytics, data engineer, data wrangler. These are all the job names in the data science field. And you know that there are a lot of digital footprint. Actually, recently the Satankulam police station issue, if you just browse, you will get hella number of information, hella number of documents, huge number of documents. Okay, so you just click COVID-19 dataset, you get a lot of information. So likewise, the digital footprint is so much that you can get lot of information, lot of the knowledge discovery, etc., etc. So the digital footprint has created a lot of data which needs to be understood, which needs to be processed so that you can do business intelligence and then prediction. In addition, you have internet, a huge voluminous data, IoT. IoT, a typical example I can say CCTV camera. CCTV camera is also kind of IoT. It collects lot of information because it is being on for 24/7, and whatever it has, if you store it and then keep it, it is voluminous and it is being heavily used in recent time. In addition to IoT, I mean the surveillance, you have medical IoT. Each and every patients of patients on the high-end hospitals, they are monitored every time to get their health information. It's called health informatics. So a lot of sensor attached, so you call it as IoT. Social media. So put together, the concept is called
Sorry,
digital
sir, your
trace.
voice is
Actually, I
breaking,
tell
sir.
you,
Sorry, sir, your voice is breaking, sir.
why is that? Now,
Just now it's okay, sir. Just for 3 to 4 minutes back, it started breaking up.
okay. So, the digital trace is so huge, and then people started, using it for forensic information. Say, I can tell you, if I can take your phone, then you unlock your phone and then give me, I will collect lot of information about individual. And that is the reason people never give the phone with lot of locks and other things. So phone has got lot of digital trace. So if I know the digital trace of a person, I can immediately tell who is that person, what is that person, and how is that person. But when you have all these, the importance, etc., etc., the educational system in India for data science, it's not adequate as far as syllabus is concerned, as far as curriculum is concerned. It is inadequate. But new universities, especially private university, has come up with a lot of a specialization aspect for data science for BTech students, and even they have started a stream. So now it is fetching up, so that maybe after 1 or 2 years you'll get very good students with the data science knowledge. Okay, and I'll tell you there are a lot of demands for the data science, data scientist in other countries, even in India. There are huge job markets. Okay, and if you have, say for example, 4 to 5 years of experience in data science, analytic, etc., etc., your salary will be in the tune of 1 lakh US dollar to 1.5 US dollar lakh US dollar, if you are a very good material. Okay, and I'll narrate some of the use cases so that you can understand where you can really explore. Use cases in the sense that application domain, and that is the term used in IT industry. Say, I have a blog or I have a user review. From the user review, I have extracted repair, not working, slow. So this is a set of text information. Then another set of text information is trouble, frustrating, waste. Another set of text information is refund, return, escalating. Now, if I am in a position to process it effectively, my algorithm should say me that there is an user, he has purchased something, and that is not working, and he is thinking that that is waste, and he is requested for refund, it is not coming. So this is a kind of understanding my algorithm should have when I read this. Repair not working slow, trouble frustrating waste, refund return escalating. Yeah. Okay, this is how the entire manufacturing industry and the e-commerce web portal uses the review or comments of the user for improving their business model. Another domain of this use cases is HR analytics. Actually, in industry, what's happening? There is a concept called attrition. Anyway, in university colleges, there were attrition in computer science. Nowadays, no one is moving to any places. Okay, so HR analytics is one of the concept where if you recruit a person and you will spend around 20 percentage of his annual income on his training, especially the high end domain area. Now, what is the guarantee that he will be in our company for next 5 years? Okay, people started using analytics, HR analytics. So if you find that an employee, a good material, is trying to leave your company, and if your analytical algorithm says that there is a probability that the staff will leave the company, immediately HR will approach and then ask him or her to continue. But if you don't do that, finally you'll see the candidate in the exit interview and then say that okay, bye, etc., etc. So it is a kind of the investment analysis, return of investment analysis. Because in industry, people do invest on HR, okay, so on training, medical, etc., etc. So this is another applications or another use cases. Very important application is customer lifetime cover value, lifetime value offer. So it is written as customer, some spelling mistake, I'm sorry for that. Actually it is like this: when you enter into a mall, since you all in Trichy, definitely you would have visited Chennai Silks, Reliance, Femina. Okay, you would have given a card. They will say that it is a customer card. Okay, and we all think that we are all privileged customer, so that we got all these cards, and then we'll be purchasing and we get some reduction or offer. Actually it is not like that. Here the purchase pattern of each and every one of us is being analyzed. What do you purchase, when do you purchase, how do you purchase, in the sense whether you pay cash or card, what is the bank. So all those information is collected through this card. Okay, so now next time they will think of offering you something. Okay, say for example, if I offer I mean offer is given on a product, whether this customer will purchase it or not. So those kind of analytical skill understanding is happening on our customer life card. Okay, and in addition to that, crime prevention, there is a terminology called event detection, crime event detection. So a lot of research is being happening. Healthcare analytics, very good understanding. Mm, the best example is Professor Dr. Maluk Muhammad. So I have visited his office maybe last May, 1 year back in STPI IIT Chennai Scientific Park, Research Park. So he is doing, his work is basically the pure healthcare analytics. So the information, the data from each and every individual is available to him through a sensor, and based on which he will do some analytics and give the food prescription and then medicine prescription. So your health is being monitored every second. So likewise, there are so many advances. and that is how the data science and its applications goes off. Now further, I have around 6 steps. So if you are into data science and if you are trying to solve a problem using data science concepts, you have to follow a sequence of steps starting from 1 to 6. Now, if you have any problem in any of the steps, then you'll have to come back and then do it. Otherwise, you never get the good result. So, as far as the first step of the life cycle of data science is concerned, define the problem. Actually, in software engineering, you might have studied, problem statement, etc., etc. So, defining a problem is very, very important. Okay, if you don't define a problem, you do not know what are you going to solve. So creating well-defined problem statement, okay, is very crucial and critical. And what is that? It is a brief description of the problem. Say I have written 3 sample problem statement. Predict the pass percentage of a group of students next semester. Say for example, you taught a class section A, and same section we are going to teach next semester. Can you predict the pass percentage of a group of students? It's a kind of problem statement. Predict whether a customer is going to purchase a product given an offer. This is also a sample problem statement. Predict the likelihood of getting a job in Google of a student. It's a problem statement. So the problem statement has to be crisp, short, and then it should be understandable. Okay, but if your problem is big, the problem statement also will be bigger. Now have this tree structure. It is basically a binary tree structure kind of thing. As I said earlier, you need to ask questions to understand what is there, and you need to ask questions even if you don't understand anything. The questions only will give you the in-depth understanding of any problems. Okay, so here things we know, and then things we know. So if you follow that know and we know, then that becomes fact. Then things we know and we don't know, ask questions. Okay, so you know but you don't know something, ask questions so that you are getting clear about the domain. Then things we know with the don't know combination, apply your intuition to get the understanding. And things with the don't know and we do not know combination, go for exploration. You need to explore. That is what exploratory data analysis, so that you get the idea about this. This is the step 1 of the life cycle. The second one is data collection, because the data science is on data, and if you do not have data, that's it, gone. You have no job. So the data collection is the step 2 in the life cycle of data science. And then this collection procedure can be a systematic approach, so that you go and collect the relevant information from various sources. Okay, it could be a single source, it could be a multiple source, or it could be a combination, heterogeneous. Okay, so it is a systematic approach of collecting the data. Now, how do you collect the data? There are 2 ways by which you will collect. Okay, primarily, one is primary data collection, another one is secondary data collection. Primary data collection is that you have all the data in the structured format, data in the structured format or whatever it is, and you go and collect it. Secondary data collection is that you have data in one form and you will be modifying that in another form. You have data from multiple sources, so you collect, aggregate, augment, okay, and then use it. So this is the secondary data collection. I've shown a sample data. It's basically a football team data. So it is a team information, name of the player, age of the player, overall weight, terms of contract, ID number, height, weight, okay, whether for rightful player, etc., etc. So this is sample data, a structured data. So it's very important to have data collection. Another important step is data quality check and remediation. I have told you when I have introduced data remediation is very, very important topic. Okay, so this is third step in the life cycle of data science. Say, for example, it is like this. I have an algorithm. Algorithm is very good algorithm. Say, for example, I did a lot of research and then got the algorithm. Now my input is wrong. I cannot blame my algorithm because the output is going to be wrong. So the same scenario here, since you work on data in data science domain, and if your data itself is wrong, here wrong in the sense that it is because of errors. The data is, if it has errors, some missed values, etc., etc., output definitely will not be perfect. So it is said if the data is bad in the sense that quality, it gives the misleading information because the prediction will go wrong. So it will be a garbage in and garbage out. You cannot really um, 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 claim the algorithm as a bad one. Okay, so you can say that if the data is very perfect, means the quality, then the output can be claimed to be a quality one. There are a lot of things we can discuss here. What do you mean by the quality of data? Okay, etc., etc. There are a lot of things, but it has to be error prone. The first term I can use is that error prone. The data I have given for an algorithm for predicting something, the data has to be error prone or error free. So I say this is the quality data. Then the fourth step in life cycle is exploratory data analysis. I have told you this as well. So before modeling the data, and you need to analyze the data. Once you repair the data, that means you have error prone data or good quality data, you can go for exploratory data analysis to understand the features or understand each and every column, understand each and every field. And from there, you will be extracting the features, okay, or you can call it as useful information or useful patterns, etc., etc. So this will be very much useful or base to get something for the data modeling solutions. Okay, and if you skip this, definitely again you will be generating inaccurate results. Earlier case that will be error, but here the results will be inaccurate or the model will be inaccurate. Okay, so you need to have the EDA. Based on the outcome of EDA, you will come up with a model, and if your model is perfect, that's it. So if you want to make your model perfect, you should perform EDA. I've given some of the visualization method. In general, EDS uses a lot of visualization so that you'll understand or have insights into the data, because you cannot just simply browse the data and then get, because since it will be voluminous with lakhs and lakhs of rows and columns, so it will not be feasible to go row by row. So visual tool will be giving some of the visual tool I have shown, visual graphs I have shown uh, respect to different teams, Liverpool teams and then Leicester teams. So kind of review I am making. Okay, so what is a winning matches, home versus away. I mean, likewise, some discrimination. So another important life cycle is data modeling. So you can see that we are going in a sequence, and each and every sequence has its own significance, and you need to do all this to get a very good prediction and classification model. The fifth one is data modeling. So modeling is basically algorithms. That is where the computer science, the mathematical, the core computer science. I don't mean that. It doesn't mean that others are not core computer. Everywhere computer science, but in general algorithms, in the sense that we immediately pop up. Okay, it's my field, etc., etc. So modeling is nothing but formulating every step. Okay, and gather techniques required to achieve the solution. Now here you will be listing down and the flow, okay, a kind of flow chart, what will be the calculation, okay, and steps, etc., etc. It's a kind of sequence of flow chart or algorithms, whatever the term is popular, familiar to you can follow. Now here, the important factor here is that the calculations, you need to do some calculation. So here, say for example, I have shown something, and there are a lot of algorithms or statistics, machine learning algorithm. I can name a lot of machine learning algorithms starting from neural network, random forest, support vector machine, KNN. Likewise, there are a lot of machine learning algorithms. So now all the machine learning algorithms works on the data. So put together, you call it as a model. Now here the picture shows there is a kind of understanding or modeling about the teams. Say for example, I have all the teams. The data I have shown. From that, I have taken only top 6 teams. From the top 6 teams, I rank them based on the clubs, based on the player skills. On the right hand side, I'm ranking based on the performance of previous seasons. So it is a kind of things I'm making a binary classification based on the data available, and then I'm aggregating it and then finding the winner. So it is a kind of prediction. Okay, so now how do I discriminate these 6 teams? Data. So there is an algorithm, and again there is a classification. So data is being divided into 2. So there is an algorithm, and combining both of them. So there is an algorithm, and then prediction. There is a machine learning algorithm. So very simple way to understand this. Having 6 teams and then predicting their skills, predicting their performance, combining them, and then finding the current winner or who is going to win. It's a kind of prediction. So the last step, data communication. The communication here refers to the way I present my result. As I told you, in general, when you work with data science, most of the time your result will be in the form of charts and graphs. As I told you, you cannot simply browse the rows, columns, and get the ideas because it will be huge. Volume is very huge. So as a result, people do always explore or present the result or communicate the result in terms of charts, etc., etc. So in that circumstances, you need to have better understanding of your presentation, okay, and you need to uh, uh, be very critical. The sense that when you are presenting a result, very specific, and your conclusion should be specific, and your critical findings should also be shown to the users. And in general, you see that, say, being you say, for example, my understanding now, say for example, I am talking to you, I am discussing with you. In the background, my presumption is that all of you are from computer science domain. But in the reality, in industry, it never is going to be. I'm so good at exploration. I got all the modelings. I got the result. So when you go and present user, and I should think that he is a computer science expertise. He may be a non-computer science expertise. He may be from different domain. So you need to have the communication or presentation which can handle non-technical audience as well, such as marketing and business executives. So you should not think that it is for computer science. The presentation I'm going to communicate, it will be understandable to everyone. This thought should be removed. And you need to communicate the results in a simple and which will be understandable to everyone. Okay. And all these stakeholders should be able to chalk out a kind of action plans from the understanding. Whatever they look or whatever you communicate should be useful to them, so that they are coming out with the actionable plan. Okay. And some of the important things are that you should know your audience, and then you should speak their language so that it reaches them effectively. And you should focus on values and then outcomes. Means whatever you give them, and what is the value, how does it improve their business model, how much profit it is going to have, what is the return of investment. These are all values and then outcomes. If there is no values and then outcomes, no need of purchasing your solution, etc., etc. You should highlight it. And also you should communicate the assumptions and then limitations of the solution you are proposing. Okay. So this is what I thought of discussing with you, and this is the reference from where I know the material I have taken. So I've got the text from this, and then a small simple text, because I don't want to show the programming today. And then this is what this thing, I think I'm done with. Um, um,
Thank you, sir.
yeah,
Is there any questions from its audience?
if you have any questions,
Yes, sir.
In general, no questions are asked. Not
Sir, I'm Shanmupriya, sir. I want to know a basic difference between machine learning and data science, sir.
machine learning is kind of actually, it is like asking the difference between horse and elephant. Machine learning basically a subject where you have a lot of algorithms. So it understands the data, it understands, and then the algorithm gets trained so that it learns. So you call it as machine learning. Say, for example, if you type in something in Gmail, so automatically, if I reply your mail, if I say dear madam, then immediately it says that Shanmupriya ma'am. Okay, and then it gives a lot of suggestions. So these are all some of the algorithms. So machine learning mostly on algorithms, but data science is science will talk about data more, and then the algorithms less. But it has the algorithmic concepts, machine learning algorithmic concepts also. But more emphasis is given on data analytic, data wrangling, data engineering, okay, data analysis. Likewise, there are a lot of aspects.
Thank you, sir.
Can I
Any
have a
other
question?
question?
Can I have a question?
Yes,
I am Shaker.
please go ahead.
Sir, you are talking about the data analytics being taught in universities, colleges, and all of that.
Yes, yes.
The industry never teaches, but it really works on that with the latest gadgets and the latest devices. Only very few people there in the design know about the entire thing about data analytics and work. The rest of the people are working on it. In industry, when they recruit people, nowadays they look at the profile of the person from the Facebook, from all social media areas, and then recruit. Whereas in universities and colleges, especially in IITs and so many other things, the number of suicides that are committed by the students are more. You are all an expert in teaching data analytics. Whether any university or college has done any project to collect the student data, looking through the various social media profiles and other things, and analyze And during the course of the 3 year or 4 year, are they doing any data analytics work other than simply teaching data analytics from the book to the student?
Actually, there is a concept called profiling. Now, there is a domain popping up is university analytics. The job of IQAC department, you might be having one IQAC department, and now it has changed. It is not only the collection, the document collection department now, because it has to talk equality. Okay, wherever there is a deviation, if university really interested in understanding themselves, so the concept is university analytics, and each and every the parts is being modeled, and the modeling is called profiling. So the profiling is classified, understood. There are a lot of set theory concept. Even we have done a lot of things. Okay, so it is not only the teaching, the entire understanding of the university is happening everywhere now, because maybe I can talk about SRM. SRM AP has invested around 1,000 crore, around 800 to 900 crore there in Amravati for the last 2 to 3 years. A huge investment, and the purpose was to establish a world-class university. Now they are looking into a kind of understanding what's happening to the money and whether we are meeting the objectives. So the domain which is popping up is university analytics, and which is being done heavily. I mean, a lot of research is being happening. I hope I have I answered your questions. Or...
Okay.
Thank you, Shekhar sir. Any other questions from audience side?
Okay, there is no question.
If there is no, yes.
Yeah.
Yes, sir. Now I request HOD of Computer Science and Engineering Department, Madam Devika ma'am, to give the vote of thanks.
Thank you, sir. Good morning to all. Honorable Speaker, Dr. Vadivel, Associate Professor, Department of Computer Science and Engineering, SRM University, respected HODs, faculties, and all the participants, it's my privilege to have been asked to propose a vote of thanks on this occasion. On behalf of the management, I extend a very hearty vote of thanks to the Honorable Speaker, Dr. Vadivel, who blessed us with his presence and thoughts. I must mention our deep sense of appreciation for your excellent speech, sir. I especially liked his speech where he mentioned the real-time scenarios for data science and lot of informations about medical data, social media, and also I wonder the roles and salary packages of the data scientists. The way he explained the topic, data science nuts and bolts, is exemplary. Also, I would like to extend a special thanks to Dr. Muhammad Nizam for inspiring us. I also wish to express my gratitude to our principal, Dr. Ravi Maran, the head of the Department of ECE, Mrs. Shanmugapriya Ravi Maran, for providing encouragement and support. I am grateful to our training and placement head, Mr. Prakash, and all other HODs for giving their support to organize the event. My hearty thanks to the participants in these events, as no program can become successful with a single person. So I extend my big thanks to our department and all other department faculties, and especially our system manager, Mr. Hakim, for their support. Thank you all for making this event successful with your contribution. Thank you.
Thank you, ma'am. Thank you so much, sir. Vadivel sir. Thank you so
Thanks.
much for your presence, sir. Once again, thank you, sir.
Thank you.
I thank all the participants, sir. Thank you, sir. Thank you so much.